Thank you so much, Menno. It's a real pleasure to be here today to tell you a little bit about the work of Earth Species Project and our efforts to decode animal communication, or in other words, to understand what animals are saying. And we've heard so much already today that gives weight to why this is an important thing for us to be doing. But I want to start first by playing you an animal sound, and I'd love you to have a little bit of a think about what animal makes this noise. Anybody have any ideas? Orca, whale, we're getting close. Anyone? Seal. Excellent. That's actually the mating call of the bearded seal. He's a cute little guy. And I think what this does is just bring home to us how foreign so much of the communication of other species is to us, and how mysterious so much of nature is, despite centuries of research to try and understand it better. So much of what we already heard about from Lane. Literally, so much of nature is communicating in ways that we as human beings cannot understand, literally can't hear. And so if there's one thing that I want you to take away from this, it is that our ability to understand the world around us is limited by our ability to perceive it. And some examples of this, you had some already from Lane, but this University of Tel Aviv study done in 2019 on evening primrose flowers was essentially trying to understand whether they could sense the approach of a pollinator. And they played the flowers, a whole suite of different sounds, and then measured the sweetness of their nectar before and after. And only when the flowers were played the sound of an approaching pollinator, or a sound at a similar frequency to an approaching pollinator, did they, within literally 3 seconds, produce more and sweeter nectar. So what this tells us is that plants can hear in some way, shape, or form. And this, they believe, is due to the vibrations of the petals of the flowers and the frequency that the pollinators are using. There's further studies that show that plants actually emit sound when they're stressed. They do this at around 70 kilohertz. And I was blown away recently. I attended a lecture by David Haskell, and he really brought this to life for me by saying, plants are making these sounds at 70 kilohertz. Human beings hear at about 20 kilohertz, but cats here at 70 kilohertz. So you could actually imagine yourself at home having a cup of tea. You've forgotten to water your houseplants for a few days, and it is possible that your cat might be able to hear your plants calling out for water, and you would have absolutely no idea that this was going on around you. Another example that I find super compelling is coral larvae, which up until a few years ago, we believed that these millions of larvae, which are essentially pushed out in huge spawning events by the coral reefs, that they were just carried by the currents. They landed wherever they landed. Sometimes they survived, sometimes they didn't, but they had no intention. But recent studies have shown by playing larvae a set of sounds, and they play them the sounds actually of the reefs, sometimes they're home reefs, sometimes others, those soundscapes, they navigate intentionally toward the sound of a healthy reef. Not just a reef, but a healthy reef over an unhealthy reef. So they are intentionally navigating through sound to a place that they can be most successful. Again, we don't really know how they do this. These are tiny microorganisms. This is a great Amazonian, next one, great Amazonian river turtle. And again, we thought that up until recently that these were completely silent. They made no sounds at all. But recent research by Camila Ferrara, a biologist, has shown that actually they have a suite of more than 200 vocalizations. And not only that, the mother turtles actually communicate to their hatchlings while still in their shells in the nest. They put microphones in. So this just goes to show how much of the world is awash in communication, that we as human beings, to this theme of this conference, are so limited, we simply can't understand what is going on. Why is that important? I don't need to dwell on this. We've already heard so much about this. We, as a species and as a planet, are facing a number of existential crises, not just the climate crisis, but also the biodiversity crisis. And the two are, of course, inextricably interlinked. And we are literally losing species now faster than we can discover them. So I want to emphasize that the work that we are doing at Earth Species Project is not just about novelty. It is not just because we think it would be cool to understand animal communication. It would be really cool. It's not just because we can, we're pretty sure we can. It's because we believe this has the potential to reconnect us to nature. And our fundamental premise is that a huge driver of the crises we're experiencing is that we have forgotten, as human beings, that we are actually part of nature. And it's this disconnection and the fact that we then are able to erect barriers in our minds that separate us from other species, that allow us to continue to exploit and to destroy, rather than leading into the kind of regeneration and regenerative economies that we've been hearing so much about. So I like to think Lane was contrasting artificial intelligence with natural intelligence. We believe at Earth Species Project that AI can actually help to open the aperture of our imagination and our understanding as a species. If you think about it, kind of like the invention of modern optics, just as the telescope allowed us to look out and discover the universe, we believe that AI can help us to perceive and connect to the world around us better. So how does it do this? I'm not going to give you a full primer on artificial intelligence. There's probably many people in the audience who are better capable of doing that than I am. But I think it's useful to hold in your mind that AI basically turns relationships between words into distance and direction, essentially into geometry. And to bring that to life for you, this shape represents the 10,000 most spoken words in the English language. And so words that are closer to each other in meaning and context are closer to each other in this shape, and words that are further apart in meaning and context are further apart. So if you were to take a word such as dog, or a concept such as dog, and find its point in this galaxy, you would then be able to start to map the relationships between dog and man, and cat and wolf, fur and yelp, and start to see, using geometric relationships, the connections between these words. So if you were to solve the giant Sudoku puzzle that is all of the English language using these kinds of techniques, essentially what you have is a rigid structure that essentially represents the relationships between all words in our language. And when this was first discovered, these kinds of techniques were first pioneered back in 2017, the researchers originally thought, well, this is great, so we have an incredible shape for the English language, but of course, all other human languages are going to be very different in shape if you think about the differences in our culture, our historical context, the way we think about the world. But what is crazy is that when they actually created the shapes for other human languages, they found that, yes, they were slightly different, but if you actually rotated them a little bit and aligned them on top of each other, they were all very similar. And the point at which you found dog in each of these rigid shapes was very much the same. And this is really the basis for how we have been able to translate between human languages without using a dictionary. And it gave rise to our intuition as an organization when we were founded about 5 years ago, that it would be possible to use similar kinds of techniques to start to understand animal communication. And of course, AI has gone even further and now allows us to translate not just between written and spoken language, but between different modalities as well. I'm sure you've all played around with some of the latest applications that allow you to translate image to text, text to image. And what's essentially happening here is that you're creating the shape of language, you're creating the shape of corresponding images, you're asking the AI to translate between the two of them. And as a kind of a random experiment done by one of our co-founders using Midjourney, he prompted it to create a portrait of Chile as a person. And this is what popped out. So we are now in territory that sees everything that can be translated will be translated across all different kinds of modalities. And this has absolutely profound implications for how we start to think about animals and how they communicate. So who is Earth Species Project? We are a small, I think we were described as a do-good company by Menno. We're a small 501c3 nonprofit organization based in the US but globally distributed. And we have a really unique team, quite small, around 15 people currently, that's brought together from the academic sectors, from commercial technology, and from the nonprofit impact spheres as well. We're small, but we're growing. And what's been really incredible over the past 2 years is to see the momentum that has been created in this space. I joined Earth Species Project about 2 years ago, and when I did, talking to people, telling them what I was going to do, their reactions were a bit like, oh, well, that's very interesting. But you could tell that they felt it was very niche, very fringe, what I was about to do. Over the last 2 years, we have seen a number of different books published. These are just a couple of them. Huge amounts of media focusing on this. I think Lane was referring to the fact that elephants have names for each other. This was a story that came out just a few days ago in the press. And a number of different organizations and labs now working on this challenge of decoding animal communication. And our work at Earth Species Project is really only made possible through deep collaborative partnerships with researchers who have been studying many of the species that we're working with for decades. This is people like Dr. Ari Friedlander from University of California, Santa Cruz, who is one of the world's leading experts in cetaceans. Dr. Joyce Poole, a leading elephant expert who's based in Kenya and has literally amassed decades worth of data on elephant communication. Some of that data would have been used to drive that new discovery about elephant names that was facilitated using analysis, machine learning analysis. And this is Dr. Valeria Vergara, who has studied beluga whales for decades. Together with these partners, we have put together a technical roadmap that gives us the building blocks on the road toward decode. And not surprisingly, this being the world of artificial intelligence, it starts with a huge emphasis on data. How do we acquire the machine learning ready data sets that will allow us to start to analyze and generate meaning? We are doing a huge amount of work in that space, but also in creating the machine learning models that will allow us then to move to the stage of how do we start to classify not just the sounds that we're getting from animals, but also the movement data that we're getting, and making cross-modal associations between those two things to try and generate hypotheses about the meaning of animal signals, and then ultimately to test those hypotheses using what we call playback experiments. So the good news is that there is literally reams of data now being generated through what is a new generation of animal-born sensors. These are incredible tags that can be placed on animals that capture not just the sounds that they're making, but also the movements that they're making, the environmental context. And so they're painting a very, very rich picture of what is going on around communication that goes far beyond just a vocalization. And that was Dr. Friedlander placing a tag on a whale. So there's a lot of data, and now there's incredibly sophisticated machine learning models that are helping us to analyze the data. But this is still a very hard problem for a number of reasons, not least the fact that the context that animals inhabit is, of course, so different from ours, particularly when we're talking about cetaceans. And to bring that to life, I'm going to play you another sound and would love you to have a think about what this one is. Any thoughts? Small fish? Bat. Bird? Bat? Bat. No? That is actually a beluga whale. Crazy. Sounds like an alien modem. Just like the bearded seal, it just, it's always astonishing when you capture these kinds of vocalizations and think how foreign they are to us. And Valeria Vergara, who you saw earlier, who's been studying belugas for decades, has been painstakingly gathering data from these animals using hydrophones placed in the ocean. The challenge for her is that she actually cannot use up to 90% of the data that she is gathering, because either it's too noisy or the animals are all speaking at once. This is a video of belugas getting together in Cunningham Inlet in Nunavut. And you can see they're an incredibly social species. Think about what a rich trove of data could be gathered from all of these interactions and social happenings that are going on at this point in time. But without the tools to actually denoise that data and to separate out the recordings, it's almost impossible to make sense of them. So what we're doing at Earth Species Project is we're building AI for the rest of nature. And that means building machine learning models that allow researchers to do these kinds of tasks, to actually make the recordings that they already have useful and analyzable. But we're also going further than that to build new approaches, test new approaches to how artificial intelligence can help solve for this long-standing problem of understanding animal communication. This is a new field. So the first things that we have done in this field are to build the benchmarks so that we know whether or not the machine learning models we're building are performing well, because we can't tell as human beings. We don't yet understand animal language. So we've built the first benchmark data sets for animal behavior and for animal vocalizations. And we have now also published the first ever foundation model for animal vocalizations, which is in essence the GPT-1 for the animal domain. Foundation models being, all the large language models are foundation models, trained on large amounts of data, generalizable so that they can solve for many different kinds of tasks. And this is the approach that our Species Project is doing, not focusing on one species, but building the general tools that can help to solve decoding across many different species. And then starting to think about how we can move into a world where we have multimodal foundation models that can translate across movement and vocalizations, as well as environmental context. And these models are helping us already to establish vocal repertoires, essentially the vocabulary of a number of different species, everything from orangutans through to jumping spiders, incredibly. And that, once we have those vocal repertoires, that takes us into the space of how can we now start to unlock understanding and generate meaning from the analysis that we're doing. So I just want to play you a quick video it's taken from a documentary called Fathom, produced by one of our partners, Dr. Michelle Fournet.
The oldest cultures are not human. They're from the ocean. 40 million years ago, before we walked upright, before we sparked fire, whales evolved to build relationships in the dark.
I'm trying to start a conversation is the most basic way you can say it. I'm trying to put a speaker in the ocean and talk to a whale and hope it talks back.
Starting playback.
If this work is successful, it will be the first experiment where we have engaged in a dialogue with a humpback whale.
So Michelle is essentially trying to say hello to a whale and see if it says hello back. But the next question is, how can we now, with the power we have with generative AI, ask something more complex? Can we generate a novel vocalization and actually get into the space where we might have a two-way exchange with another species? And we are actually just in the early stages of doing these kinds of experiments with a captive population of zebra finches, working with partners at the University of McGill. Zebra finches are a model species. They've been studied for a very, very long time. So it's actually the perfect kind of opportunity to start to test this. And I just want to play you a super quick vocalization. The first part of this, before the line, is recorded from the zebra finches. The second part is generated by the AI that we have developed. So you can see it's pretty much indistinguishable. And this is definitely putting us into incredibly exciting territory, where we're actually probably in the next few months going to be able to get into this first ever two-way communication with another species. But the crazy part of this, of course, is that we likely will not understand the meaning of that exchange that is happening. And that also puts us into very risky ethical territory, because we have very soon within our power the ability to communicate with other species potentially without knowing what we're saying. And that means we could be interfering with what, if we're thinking about cetaceans or whales, 34-million-year-old cultures that we could be messing with. So we need to go very, very carefully with this. We need to build the ethical guardrails around it that will make sure that we are doing no harm with this and deriving positive benefit. So this brings me back to where I started. In a world where we're losing species faster than we can discover them, if we can understand what animals are saying, how will that change the picture? I think there are many, many different kinds of applications here, but want to return again to the fact that it's not about novelty. I mean, most people, when I talk to them about this work, they say, great, so when can I talk to my dog or my cat? It's not about enriching the lives of human beings. It's about fundamentally understanding nature and natural intelligence better. If we can do that at a most basic level, we can design more effective conservation interventions. So if you could understand what whales and dolphins are saying, how might we be able to avert those mass stranding events that happen on a regular basis? How might we be able to avert human-wildlife conflict, the kind of conflicts that are happening on a regular basis with wolves here in Europe, with bears, with elephants in Africa? But I think this could be much larger as well. I think this could create a really fundamental shift in the way we think about ourselves in relation to the rest of nature. And if you could understand what a whale or a frog or a bird was saying, might that add power to the Rights for Nature movement? How might it change the way we think about animal welfare for the thousands, millions of animals kept in captivity on factory farms? Might we even take a step further and start to think about ways we could represent other species in decision-making processes? Not necessarily just in our processes, but in processes that potentially we design in partnership with them. It sounds crazy, but it's actually not that far away. And as you think about your own roles in business, there's already so much of a movement towards stakeholder capitalism. How can we start to think about the rest of nature as key stakeholders? So we believe that this work really has the potential to open new scientific frontiers and open new frontiers in human perspective. And so just as the telescope allowed us to look out at the universe and discover that Earth was not at the center, so our hope is that AI can help us look at the patterns and the complexity of life right here on Earth. And maybe if we can do that, maybe we can discover that humanity is not at the center. Thank you.